We're asked to define a function called countLs. It takes one parameter, a list of strings. And in the example, they call it my list as the thing they're passing to the function. I don't have to call it that. There's a, I don't know what I'll call it. It's a list, so maybe I'll call it L. If I call it S, I'll confuse myself. And it returns the total number of times the character capital L or lowercase l appears in the strings. So it has a return value. I'll call it answer. So we're trying to figure out the answer. Now, we could do the accumulator pattern because we're just counting something. But we are counting something repeatedly. So we have to loop over the elements of the list, and then we'd have to loop over the characters. There might be some fancy methods we could use. But I don't recall any off the top of my head. So let's just do the normal pattern where I need a loop. I need to loop over the things in the list. So this is a list of strings. So I could say for S in L. So that's a loop that will give me string by string by string. So now I need to then count how many L's are in each string. So I would just use another loop to do that. Right, say for character in S. And I'd say something like my accumulator pattern outside the loop, I need to initialize my accumulator variable. So I'll accumulate it I'll start at 0. And then I'd say inside the loop, only if something is true. If C is equal to uppercase L or C is equal to lowercase l, then I want to count it. Answer equals answer plus 1. That'll do the job. So let's add in some cleverness for people that are ready for that cleverness. I could have simplified this logic by saying for C in S dot lower or dot upper. Change that string to all uppercase as I loop over it. And that would mean I don't have to OR, because now I'm only looking for uppercase L's because everything is in uppercase. I could use that syntactic sugar that is this is actually answer plus equals 1.